वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल स्टडी द हाइड्रोकार्बन चैप्टर ऑफ क्लास 11th, alkene. So what's about the alkene? So let's start with the alkene. Alkene. As you know, the general formula of alkene is CnH2n and it have a suffix. That suffix is ene. Now here, there must be one double bond between two carbon, so one double bond is essential for alkene, and so that's why n must be at least 2, 3, 4, 5, anything it may be. In place of n, if you put the 2, then it will be C2. H2 into 2, that is equal to C2H4. This is the 2 carbon alkene. So 2 carbon is eth, and we put ene, ethene. Now this is the molecular formula of the ethene. Now what's about the structure formula? So you have to write 2 carbon and put a double bond between 2 carbon and satisfy the tetravalency of each carbon. So it is like this one, and this is the structural formula. Now if you want to write for the 4 carbon, just write down yourself the 4 carbon, 5 carbon, 6 carbon, 7 carbon alkene. So I'm just giving the one example of the 6. So n is equal to 6, then C6H2 into 2, 2 into 6, then C6H12. So hydrogen is twice the number of carbon. So this is hex and ene, hexene. Now I'll just write down the structure formula. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 carbon. Put a double bond over here. So satisfy all the tetravalency. Satisfy the tetravalency of all the carbon atom present in hexene. So it will be your structure formula of hexene. So now this is the IPSC nomenclature. Now we have to, I'm just giving you some more structure of alkene. So you have to give the name of these alkenes. So have a look here, like what the name we will give to this one: CH3, CH2, CH double bond, CH2, and put over here this is the CH, suppose CH, CH3. So this is first one. Now the second one I am giving you, this is the CH3, CH, CH3, CH3, and this is the CH2, CH double bond, CH2. Now the third one we have like CH3, CH3, no, and C2, H5, and CH2, CH double bond, CH2. Now so you have to start the counting from this one. So 1, 2, 3, 4 carbon is a bute, so bute 1 in, so bute 1 in or the butene simply, and at third position there is one substituent of methyl, then 3 methyl. So this is your answer of this question. Now let's start from here. 1, because the functional group it is a double bond, is the more prior than alkyl group. So 1, 2, 3, 4, 5. Nah? So the fifth position there is 2 substituent. Nah? So we will give the name of 5 is the pent. So pent 1 in or the pentene, and what the name of this substance is 4,4-dimethyl. 4,4-dimethyl. So this is the 4,4-dimethyl, pentene. Now again this one 1, 2, 3, 4, 5. Okay, now this is the longest and you have to find out 1, 2, 3, 4, 5. But now this is, if you move this side, then 5 and 6. So this is the longest one, 6 carbon. 6 carbon is hexene, now, and at fourth position there is 2 methyl. So again this name will be 4,4,4,4 dimethyl hexene. Now this is the nomenclature. Now we have discussed about the nomenclature in organic chemistry in the earlier chapter. Now we'll just move towards the preparation of alkene. How you can prepare the alkene. So methods of, what you write? The methods of preparation of alkene. Methods of preparation of alkene. So how you can prepare the alkene? So alkene can be prepared with a different method. Anyway, the first one we have, let's start from alkyl halide. First is from alkyl halide. So alkyl halide is what? Alkyl halide is Rx, where the X is what? X is your halogen. Halogen, it may be your fluorine, chlorine, bromine, iodine, just like this. So this is the alkyl halide. Now, so how you will prepare the alkene from alkyl halide? So when alkene undergoes, when alkene reacts with what? Alcoholic KOH. Alcoholic KOH. Now, sorry. When alkyl halide reacts with alcoholic KOH, it forms corresponding alkene. So it will form the corresponding alkene. So have a look here how. One most important thing you should keep in mind. Basically this is the elimination reaction in presence of alcoholic KOH, and this is known as the dehydrohalogenation. This process is known as the dehydrohalogenation. Is what? Dehydrohalogenation means removal of hydrogen halide. Removal of hydrogen halide is known as dehydrohalogenation. So you should keep in mind. So in this case, have a look here. I just like to give you one example. Like we just take any alkyl halide. Like this. Suppose we just take the example of this one. Simply we take the example of this one. This is chlorine over here. So in when it reacts with alcoholic KOH, so KOH, and this is it must be alcoholic. You should keep in mind it must be alcoholic. Otherwise it will give you some other product. What the product it will give you, I will just explain you later on. So dehydration is what? Dehydration is a elimination reaction. Is what? Elimination reaction. So dehydrohalogenation is elimination reaction. So elimination of hydrogen halide took place here. So this is known the elimination reaction. And this is also what? Halogen is out from alpha carbon. This alpha carbon is what? The carbon which is attached to the functional group, that is known the alpha carbon. So this is the alpha carbon, and this is the beta hydrogen. This is the beta carbon, and hydrogen attached to this is known as the beta hydrogen. So now what will happen? A hydrogen is removed from the beta carbon, and a halogen is removed from the alpha carbon, and such type of elimination is known as the beta elimination. Is what? This is known as beta elimination. Beta elimination. Why it is the beta elimination? Because removal of alpha halogen and beta hydrogen. So that's why it is known as the beta elimination reaction. So how it will proceed? So KCl will out from here, and H2O will out from here. So KCl plus H2O is a byproduct, and since there is a to satisfy this tetravalency, we have to put a double bond over here. So it forms this is your ethene. So this is your chloroethane. From chloroethane to ethene, this is your ethene is formed. So this is what? Dehydrohalogenation. And whatever the dehydrohalogenation, this is the beta elimination. Removal of why it is known as the beta elimination? Because alpha halogen is out, is okay, but second is out from beta position, beta carbon atom, the hydrogen of the beta carbon. So this is known as beta elimination reaction. Now we just move to the next one. Next one is what? Next one is just like this. If in such type of the condition, there is some condition is over here. Like, have a look here. If you want to do the dehydrohalogenation of this compound, so what will be the structure? This is the CHH, and this is, suppose this is the CH2, and this is the CH2Cl. Now, so basically, as you know, if you take the alcoholic KOH, so what will happen? So is the alpha hydrogen and beta alpha chlorine, and that is a halogen, and beta hydrogen. So you can write here just like this. This is hydrogen like this, and this is, you can put the we can put the chlorine over here. So HCl will out. How? It form KCl, and it will form KCl plus H2O, and to balance that, you have to put a double bond between two carbon over here. So this is what? This is your chloro butane. Is what? Chloro butane, and this is what? But1ene. Yeah, that's butene. So from chlorobutane you can form the butane or but1ene. Now this thing will change. How? Have a look here. If you take the compound just like this, CH3 CH2 CH Br over here, and this is your CH3 now, and you just take the alcoholic KOH over here, alcoholic KOH. Now what? Now there is two possibility. What the possibility is? One possibility, then this hydrogen can take part. This hydrogen can take part in the dehydrohalogenation, or this carbon can take part the dehydrohalogenation, because both are the alpha hydrogen. Both have the alpha hydrogen, because this is in middle. This is the, so both have the beta hydrogen, because this carbon is the alpha carbon, and this one is also beta, and this one is also beta. So there is two possibility. Either what the possibilities are, have a look here. So there is one possibility is this key, it can form dehydrohalogenation can take place from this side, and the product will form just like this, CH3 CH2 CH double bond CH2, or otherwise if elimination will take place from this side, so what will happen? It will form CH CH3 CH double bond CH CH3, just like this. There is two possibilities over here, but this is now we have to study about a rule that is known as the Cbse rule. So what the Cbse rule is, and according to Cbse rule, which is the real product, or which is the more stable product, and which is the less stable product. So have a look here. First let's study about the rule, what the Cbse rule is, then we will discuss about that one. So what the Cbse rule is? Cbse rule. So it is simply, it states that more alkyl substituted alkene is the major product. So more highly substituted alkene, more highly substituted, more highly substituted or highly substituted alkene gives major product, major product means a stable product. So according to this one, if you consider the elimination from this side, then double bond will come over here, and double bond is over here, but this side is alkyl group is okay, but this side there is no alkyl group. On the left side of the double bond there is alkyl group, but on the right side of double bond there is no alkyl group. But as in this case, double bond is over here, left side is also alkyl group, and the right side is also alkyl group. So according to the Cbse rule, more highly substituted alkene gives major product, then out of these two, this will give you the major product. So this is the major one, and this is the more stable, major as well as more stable, and this is less stable, or simply we can say this will give you the minor product. So basically this gives near about 80%, and this gives only the 20%. So this is very important one. So you should keep in mind the Cbse rule during the formation of alkene. Now have a look here. I just like to give you one more example. So suppose we have such type of example like 1, 2, 3, 3 carbon over here, and then again we put a CHBr over here, then a CH3 over here. So this is what pent 2-bromopentane. Now this is what 2-bromopentane. If it is 2-bromopentane, so what do you think? If it will undergoes reaction with alcoholic KOH, now so what the product it will form? So there is two possibility again. Either it will form this side double bond, or it will form this side. Now so it will, if it will form double bond this side, so the product will be just like this: CH3, CH2, CH2, CH double bond CH2. And if it will form from this side, suppose it will form from this side, now then what? So it will be what? It will be CH3, CH2, CH double bond, CH3, CH2, CH double bond over here, and CH CH3. Nah? So 1, 2, 3, 4, 5. Nah? Is a double bond over here, then CH and CH3. Now as in this case, this is known as pent 1 in, and this is the pent 2 in. So according to which is the more stable product, so this is the pent 2 in. Nah? So which is the according to Cbse rule, more alkyl substituted. So in this case, on both the side of the double bond there is alkyl group. So this will be the more highly stable and major product of alkene will be formed. Where this side, this is also possible, but only the 20% alkene is formed of pent 1 in. Nah? And this is what pent 1 in. Pent 1 in is only 20%, and this will be less stable according to Cbse rule. So now I'll just move to the next one. We can also prepare next preparation of alkene. So we can also prepare from vicinal dihalide. Dihalide. So what is the meaning of vicinal and geminal? There is two terms. One is the vicinal. Vicinal is what, and the other term is geminal or gem dihalide. This is known as the gem dihalide. Other is known as the vicinal, means vis dihalide. Vicinal dihalide. What is the meaning of this? Have a look here. If the two consecutive carbon have halogen. If two consecutive carbon have halogen, so this is known as the vicinal dihalide. If the same carbon have halogen, suppose this is the carbon, this is hydrogen, and if the same carbon have two halogen, so this is known as geminal. This is what geminal. This is your geminal. This is the vicinal, and this is your geminal. The same carbon have two halogen, then this is the geminal, and the two consecutive carbon have two halogen, then this is a vicinal. So now what we are taking over here, we are taking the vicinal dihalide. So how just write? When vicinal dihalide react with vicinal dihalide is what? At a 1 and 2 position. 1, 2 dihaloalkane. 1, 2 dihaloalkane. Now in this case, this is the ethene. ethane, so we can write 1,1,2 dibromo. This is the dibromo ethane. So 1,2 position is the halogen at 1,2 position, that is the what? That is the vicinal. And if at a 1 position, so now this is the 1,1 dibromo ethane. So at the halogen at same carbon, 2 halogen at the same carbon, this is not the geminal. And the 2 halogen at the adjacent carbon, this is not the vicinal. So now, so when vicinal dihalide react with what? It react with zinc and alcohol. So what will happen? Dehalogenation will take place. Dehalogenation will take place and results into alkene. So now have a look at what I want to say. I have used the term in earlier. We have used the term dehydrohalogenation. This is the dehalogenation. Dehalogenation means removal of halogen. Have a look here. If you take, I am giving you the example. Same molecule I am taking. CH2Br. This is the 1,2 dibromo ethane. When it react with the zinc in presence of methanol or something like methanol, we take alcohol in presence of alcohol. So methanol. So what will happen? So reaction will proceed just like this. It will be ZnBr2. ZnBr2 will out from here. So ZnBr2 means removal of halogen, and what will happen? What will be left behind? This is the CH2, then CH2 double bond CH2. So this is your ethene is formed, and there is a removal of halogen, that is the removal of bromine in the form of ZnBr2. So this is the dehalogenation reaction. We can give some more example over here. One more example I would just like to give you. Then what will happen now? Sometime the geminal is also required over here. Geminal, we can also use the geminal over. Now wait a second, I am giving one example like CH3 CH Br and CH2 Br. This is the 1,2 dibromopropane, and with the zinc in presence of methanol, then it will give you ZnBr2 is out from here, and it will give you propene, CH3CH double bond CH2 plus ZnBr2. Like the next one, geminal dihalide also undergoes dehalogenation. I have told you what the geminal dihalide. So if you take the like CH3 CH2 CH, and it have two bromines at the same carbon. So this is known the 1,1 dibromo propane. So 1,1 dibromopropane will react with the zinc in presence of methanol, then it will also form ZnBr2 from here, and to balance this, their double bond will come over here. So this is this will be what? This will be your compound like CH3 CH double bond CH2 plus ZnBr2. Reaction doesn't take place just like here only, because there is a shifting of high proton will take place over here, but the product will be same. Product will be formed just like this only. So you should keep in mind. Now I'll just move to the next method of preparation of alkane. So what the next method of preparation of alkane? We can also prepare it from what? Alkane. So by partial from hydrogenation of alkyne. Now we can prepare the alkyne. So by partial reduction of alkyne. Alkyne is what? Having triple bond. So when hydrogen added over here, then it will form alkene. But partial, here the term is partial reduction. Now partial reduction. If the complete reduction will take, it can form alkane. Now, so you should keep in mind during the solving such type of the question. Now here, when alkyne is reduced with what? So with Lindelar catalyst. Lindelar catalyst. So Lindelar catalyst is what? Lindelar's catalyst. So Lindelar catalyst, basically we say this is the palladium plus CaCO3 plus sulfur. Now this is the Lindelar catalyst. So when alkyne is reduced with Lindelar catalyst, it forms cis alkene. Okay. Now wait a second. How it will form a cis alkene. So wait a second. This is what I am taking over here. Suppose I am giving a example of. I am taking example of CS3 C triple bond CS3. So when it undergoes hydrogenation with what? With a catalyst, that's the Lindelar catalyst. So which is the Lindelar catalyst? Palladium plus CaCO3 plus sulfur. So what it will give you? So after the hydrogenation, it will give you this bond will break and one hydrogen will get attached over here, one hydrogen will get attached over here, then it will give you a molecule just like this. How I have written this like this? So this is the same thing as it will hydrogen will wait a second, as this bond breaks, then what happens? So one hydrogen get attached over here, one hydrogen get attached over here. So one hydrogen, if you write just like this, so you can understand easily, this bond will break, one hydrogen will get attached over this side, one hydrogen will get attached to this side. So the structure is just like this. So this is what? This is the bute 1 2 3 4 2 in. Now what about the cis and trans? Then I have a video of stereo isomerism, in which we have discussed about the conformational isomerism, configurational isomerism. In configurational isomerism, we have discussed about the geometrical isomerism. So in geometrical isomerism, we have discussed that if a alkene like this have a alkyl group attached, or any groups attached, suppose the same groups are attached on the same side, this is known as a cis. Cis means together. Cis means together. Together. And if alkene is just like this, where the same alkyl group or groups are on different side, like B, A is over here, other A is this side. One alkyl group is CS3 is over here, CS3 over here, one hydrogen is here, one hydrogen is here. The same type of groups are on different side. Then this is not trans. Trans means opposite. Trans means opposite. So when you see my isomerism video of the isomerism on stereo isomerism basically. So there I have discussed about the geometrical isomerism. So in geometrical isomerism, molecular formula is the same, structure formula looks is same, but there is a difference in space arrangement. Space arrangement difference is due to what? Different geometry. Different geometry is what? If the same groups are on same side, like here the AA are on the same side, so this is known as cis. Cis means together, and the same group on opposite side, then this is known as trans. As in this case, same group, like what the same group is over here, this is methyl group. Methyl group and methyl group on the same side, hydrogen and hydrogen on the same side, then this is known as cis. This is a cis. So this is the cis butene. This is known as cis butene. So Lindelar catalyst, when alkyne is reduced in presence of Lindelar catalyst, very important one. And alkyne reduced in presence of Lindelar catalyst. What is the Lindelar catalyst? Palladium plus CaCO3 plus sulfur. Then it gives you what? It gives you cis alkene. Na? So this is very important one. So it will give you cis alkene. Now one more thing I just like to add you. Then in place of CaCO3, there sometime it is also written as BaSO4. BaSO4. So both are the same. Sometime it is the CaCO3 or BaSO4 is used over here. Now, so sulfur is used, and sulfur is used to poison the reaction for the further reduction. Now, so to avoid the further reduction, sulfur is used over here. So it is used as a poison. So this is known as this is what? This is the Lindelar catalyst reaction. Na? Acha. Now the next one we have. Next one is the reduction by reduction of alkyne. What do you write here? Reduction of alkyne by Birch. Basically, this is known the Birch reduction. Na? By sodium and liquid ammonia. Sodium and liquid ammonia. Na? And this is known the Birch reduction. This is the BIRS, Birch reduction. So what it forms? So reduction of alkyne by sodium and liquid ammonia forms transalkene. So we remember what the transalkene is. So this forms transalkene. It forms transalkene. I just like to give you example over here. Same example I am taking. CS3 CH3 C triple bond C CS3. This is the alkyne. Now what will happen? So we just take the sodium in a liquid ammonia. So sodium in liquid ammonia. So again this bond will break, and now this time what will happen? One hydrogen will attach this side, one hydrogen will get attached this side. As this bond break, this bond breaks, one hydrogen attached this side, one hydrogen attached this side. So we can arrange just like this side, one hydrogen attached this side. So structure will be how the structure you can write. So structure will be just like this. One is CS3 over this side, and hydrogen is over here, and here in this case this hydrogen is over here and CS3 on this side. Now, or we can wait a second. I just change this bond like this one. Now, so now in this case, this is also 1, 2, 3, 4. This is also butene. Earlier was also the butene. In this case, this is also the butene, but this is also butene. But now have a look here. Now what? The alkyl group are on opposite side, and hydrogen is on opposite side. So this is opposite side of the alkene. Na? So this is the transalkene. What is it? This is the transalkene. What I told you about the transalkene means opposite side. Na? So this is the cis and trans. So this is basically part of geometrical isomerism. Na? So it will give you transalkene. Got it? So now so this is a one type of method of preparation of alkene. Now we'll just move towards the next type of method of preparation of alkene. So Now we can also get the alkene from alcohol. Acha, one more thing I just want to recall over here. As in the case of, I just want to make as in this case of this one. As in the case of vicinal dihalide, no, not the vicinal dihalide. This is the Cbse rule. Yeah. As in the case of alkyl halide with alcoholic KOH. So one thing you should always keep in mind. This is very important. When alkyl halide reacts with alcoholic KOH, then it forms alkene. But when alkyl halide react with aqueous KOH, you should keep in mind aqueous KOH, then it will form alcohol. Nah? So this is very important thing you should always keep in mind. So when the alkyl halide reacts with the alcoholic KOH, it forms alkene, and the process is known as dehydrohalogenation. But when alkyl halide reacts with the aqueous KOH, it forms substitution reaction, and it will form alcohol. So this is a very important one you should keep in mind. So now let's move to the next topic. Next topic is what we can also prepare the alcohol from. We can also prepare the alkene from alcohol. So from alcohol. So how you can form the alkene from alcohol? So by dehydration of alcohol. And basically what is alcohol? Monohydric alcohol. Na? Monohydric means having one OH. Monohydric alcohol. Those alcohols which have only one OH. So that is the monohydric. If the alcohol have two OH, then that is known as the dihydric. So this is the monohydric. Have a look. I would just like to give you an example. Like this is C2H5OH, CS3OH. So this is the monohydric alcohol. Hydric. If you have the like CH2OH, it have two OH, so it is the dihydric alcohol. Now if it have the three OH like CH3OH, CHOH, CH2OH, now this is known as the trihydric alcohol. If it more than that, this is known as polyhydric alcohol. So as in this case, the name of this one is ethane 1,2-diol. Or simply this is also known as the glycol. Glycol is a cough syrup. Na? Glycodine cough syrup. Na? So glycol is used in the cough syrup. So this is what? This is the dihydric alcohol. Now the trihydric alcohol, its name will be 3 carbon, then propane 1, 2, 3 triol. Its commercial name is glycerol or glycerine. Glycerine is used as a fake tears. Na? So if the artist have to show the tears, then what they do? What they use the glycerine in their eyes. So they that create the fake tears. So this is glycerin is used over there, and glycerin is trihydric alcohol. But here, from alcohol, if you want to get the alkene from alcohol, what you have to take? You have to take monohydric alcohol. Only one OH should be there, na? So by dehydration of alcohol, in presence of what? Conc H2SO4. Concentrated H2SO4 is a very good dehydrating agent. Or alumina is Al2O3. Na? So dehydration will take place. Na? Dehydration will take place. Dehydration will result the formation of alkene. So we have used a different term, like we have used dehydrohalogenation, dehalogenation. Now here we are using dehydration. Dehydration means removal of water. Now D means out, removal, and hydration means water. So removal of water is known as dehydration. So how the reaction will proceed? So I just like to show you the reaction. Suppose simply we just take the ethanol. So this is your ethanol, CH3CH2OH, na? So this is your ethanol. So when ethanol is treated with a conc H2SO4, conc H2SO4, na, what will happen? One H2 is out from here, and H2 is as a byproduct, and the main to balance this balance it, then it will be double bond will become between two carbon, and this is so this is ethanol is what? Ethanol. So from ethanol we can form ethene. So this is also, this is the conversion. So it is very important one. Acha, there is a what is a the 1 degree alcohol, 2 degree alcohol, 3 degree alcohol we have. So I just like to explain you what is the 1 degree, 2 degree. So you will also learn. Acha, I'm the video is moving faster. So you can stop the video. You can pause the video, and you can understand what the everything which on the screen, and you can write down that too. It will be helpful for you. Now the thing is that I just want to explain you 1 degree, 2 degree, and 3 degree alcohol. So 1 degree alcohol is what? If suppose I'm giving CH3CH2OH. Now OH is the carbon to which the OH is attached. Only one side have alkyl group. Only one side. I'm just telling not the number of carbon. I'm just telling one side. One side of this carbon have alkyl group. So this is another 1 degree alcohol. 1 degree alcohol or primary alcohol, or we say primary alcohol. Primary alcohol. Now if suppose we just take the example of this one. In this compound, what is the molecule? We will discuss about the IPC name later on. In this compound, the carbon to which OH is attached, two sides have alkyl. The number may be anything. Number may be anything. So we are discussing only the sides. In number, you can make a 4 carbon, 5 carbon over here, 3, 4 carbon this side. But if the two sides is the alkyl group, then it is known as 2 degree alcohol. What do you say this? 2 degree alcohol. 2 degree alcohol, or we say secondary alcohol. What do you say? Secondary alcohol. Now, now if the suppose this is the thing. Now the carbon to which OH is attached, all three sides have alkyl group. Then this is the 3 degree alcohol. This is known as 3 degree alcohol, or this is simply known as tertiary alcohol. Tertiary alcohol. So tertiary alcohol. Primary 1 degree, secondary 2 degree, or 2 degree alcohol, or tertiary 3 degree alcohol. Have a look here. I'm giving you one example. CH3, CH2, CH2OH. Whatever the alcohol it is, just tell me. CH3, CH2, CH3, OH, and this is the CH3, CH2, CH3. This is the CH3, OH. I'm not asking the IPC name. I'm just want to. I just want to know it is either the 1 degree, 2 degree, or 3 degree alcohol. Now have a look at how just get it easily. So I am just giving the simple way. If we have not to see the sides, so what do you have to do? If the carbon to which OH is attached, the carbon have 2 hydrogen. 2 hydrogen means CH2, that is a 1 degree. If the carbon to which OH is attached, only 1 hydrogen is attached to that carbon. Now it have only 1 hydrogen, so it is a 2 degree. Now if carbon to which OH is attached have no hydrogen, only alkyl groups, then this is 3 degree. Simple one. Then CH2 is over here 1 degree, CH 2 degree, and no hydrogen, then is the 3 degree alcohol. So this is the concept about the 1 degree, 2 degree, 3 degree alcohol. Now we'll just move to as a concept again. Now what are we doing? We are doing the preparation of alkene from alcohol. So alcohol is what? Monohydrate alcohol which have only one OH, but monohydrate alcohol can be 1 degree, 2 degree, 3 degree. So have a look here. In all the cases only one OH, so all are the monohydrate, although they are the primary, secondary, tertiary alcohol, but they are only monohydrate, they are not the dihydrate. So we are discussing about the monohydrate alcohols. So I am giving one example. So like CH3 CH3OH. Now in this case, the carbon to which OH is attached, only one hydrogen is there. If one hydrogen is there, then it's 2 degree alcohol. So it's a 2 degree alcohol. So if the 2 degree alcohol undergoes in presence of H2SO4, we take the Kong H2SO4, but it is a 60% saturated, concentrated. So again, it will be what? One hydrogen. We can write like both the sides, the number of carbons same. So simply we can write here the H. Otherwise we will use the Cbse rule. Nah? So it will give you CH3 CH double bond CH over here. One H2 is out, since it is a dehydration reaction. Dehydration means removal of water over here. Now we just take the 3 degree alcohol. We just take the 3 degree alcohol like this one. So this is the symmetrical alcohol, we can say, because all sides have the same number of same type of alkyl group. Now what will happen? Again, this we need H2SO4. Since 3 degree alcohol is more reactive. 3 degree alcohol, the reactivity of alcohol, if we want to write reactivity of alcohol. So 3 degree is more reactive than 2 degree than 1 degree. Nah? Because it have more inductive effect. If you remember, plus I effect, it have more, so it will easily provide the electrons to the more electronegative oxygen. So that's why the reaction will proceed very fast. So we need only 30% concentrated H2SO4 over here. So again, from any side it can take one hydrogen, and like this is the, suppose we take one hydrogen, it will form H2O over here, and that there will be double bond will form over there. So CH3 and a double bond form between these two. So we can move like this over here, or we can also write just like this, no matter the side. So the same thing, nah? So to understand the point, same thing. Is a double bond over here. So put this side. So this is what propene. So 2-methyl propene. It's what? 2-methyl propene. So this is what? 3 degree alcohol. Now this is the 2 degree alcohol dehydration. Now this is very important, reactivity of alcohol. So out of this, if they give you the 1 degree, 2 3 degree alcohol, the same carbon, then which is more reactive, than 3 degree alcohol is more reactive. Now in cyclic compound, in cyclic alcohols, we have also like cyclic alcohols, we have like this is what? This is the cyclohexanol is what? Cyclohexanol. And this have only one OH, nah? But can you tell me this is the 1 degree alcohol or the 2 degree or 3 degree? Then have a look here. If you write the this carbon, so 1 2 3 and 1 hydrogen is over here, and each have the 1 carbon and 2 hydrogen. All have the 2 hydrogens in cyclohexanol. So as in this case, can you identify this cyclohexanol is 1 degree alcohol or the 2 degree alcohol? Then see the OH, and the carbon to which the OH attached have hydrogen, 1 hydrogen, not the 2 hydrogen. If it were 2 hydrogen, then it would be the 1 degree alcohol, but now it have only 1 hydrogen, so it is a 2 degree alcohol is what? 2 degree alcohol. So you should keep in mind. Last 2 degree alcohol, so in presence of H3PO4, when you heat it, then what will happen? It will take H from here, nah? 1 H from the other hydrogen, other carbon, so it is H2 is out, and a double bond will form over here. So it will form cyclohexene. What it will form? Cyclohexene. You can balance the hydrogen carbon over here. So this is the cyclohexene. So cyclohexene. So what the thing is, when cyclohexanol undergoes dehydration in presence of H3PO4, then it forms cyclohexene. Getting the thing? So this is again what I told you. If I give you the example like CH3, CH2, CH, OH and CH3. Now in this case, from where the dehydration will take place? So dehydration will take place from either it can take place from this side or from this side. Then we should keep in mind which one? Cbse rule. So as you know, it will form. Now here also the Cbse rule is applied. What? Cbse rule. Very important Cbse rule. Nah? So Cbse rule is applied. So Cbse rule states that if either it can form this side. If it can form this side, then the structure will be CH3, CH2, CH double bond CH2. Now, if the dehydration takes from this side, so it will form? It will form CH3, CH double bond CH double CH3. Now, what I told you, what the Cbse rule states: more alkyl substituted will give you major product. So in this case, this side, both the side is the alkyl group, and this is your major product, and this is a minor product. So here is also Cbse rule is applicable. So you should keep in mind. Now there is also, you have to ask the mechanism of dehydration of alcohol. This is also important one. So mechanism is also asked. So I just like to explain the mechanism as well. So what's about the mechanism? Just see. Mechanism of dehydration of suppose we just take the ethanol, or monohydrate alcohol, or we just take the ethanol over here. Ethanol, they can ask you the question, write down the mechanism of dehydration of ethanol. So how you will write? So in mechanism is completes in 3 steps. In step 1, just step 1. Step 1 is basically the formation of protonated alcohol. Is what? Formation of, just write down, formation of protonated alcohol. So what's about the protonated alcohol? I will discuss about this one. Now what I told you, what you take for the dehydration, which catalyst we use, then we use the H2SO4. It take place in the presence of conc H2SO4, then it will provide 2H plus SO4 2 minus. Acha, if you remember, H plus is what? H plus is, I always tell you what the H plus is. So H plus is proton. Is what? Proton. How it is a proton? So you remember, hydrogen have 1 so hydrogen have 1 electron, 1 proton, and hydrogen is the only element which don't have any neutron. When it will be positive charge, then 1 electron which it had, so it will also lose that electron, and it will be no electron now. Only it will have 1 proton, 9 neutron already it don't have. So H plus is also known as proton. I hope you understand this one. Now have a look here. So now this H plus we are using, and we are taking the ethanol. Ethanol is what? Ethanol is CH3 CH2OH. Achha, this oxygen have 2 lone pair as well. So when it react with the H plus ion, this proton, so what will happen? This lacks electron, and it have lone pair electron, so it will give the electron to this one and will get attached. So it will form just like this, CH3 CH2, and this hydrogen will also get attached over here. So this is H, and it have already 1 hydrogen. So this hydrogen attached, but it will develop positive charge, because this charge will develop over here, because this have given electron to this one. So it will, positive charge will develop over here, and this is known, this is alcohol already we have, and this is proton is added to this one. Now H plus is proton, so proton is get attached to this alcohol, and what it will form? Protonated alcohol. This is what? Protonated alcohol or protonated ethanol. we are taking ethanol, then protonated with ethanol. So in first formation of protonated alcohol or protonated alcohol, ethanol took place. So this is the step number 1. Now pause this now and take just write down and study carefully. Now step 2 is what? Step 2. Now what we are in step 1, what we did, we have formed the protonated alcohol. Now what we'll do the next one. Next one is basically we'll form carbocation. So we just write formation of carbocation. Formation of carbocation. Carbocation. So what's about the carbocation? So carbocation is just like this. If you remember, if any carbon have positive charge developed, so CH3 plus, so it is a carbocation. If the minus charge is developed, this is known the carboanion. This is a carbocation. If positive charge is developed over the carbon, carbocation. If negative charge is developed over here, this is the carboanion. Carboanion. I hope you understand. Now let's move. Now formation of carbocation, how it will take place. So we have already CH3, CH2, OHH, and this is the protonated alcohol. This is your protonated alcohol, and slowly it this is the slow step reaction. So when it is heated slowly, so means this reaction proceeds slowly. So what will happen? So this oxygen, wait a second. Now this oxygen will take the electron of this bonded carbon oxygen bond, and it will form H2O. So H2O is out from here. H2O is out from here by taking the electron from the carbon oxygen bond. So one H2 is out. So H2 is out. H2O is out. If H2 is out, then what remains? So it is CH3 CH2. Now this electron, the shared pair of electron have been taken by this oxygen to form the H2O. So this carbon will lack the electron and it will develop a positive charge. So what I told you, whenever the carbon will attain the positive charge, it is known as carbocation. So carbocation is formed. So this is your ethyl carbocation. This is what? This is your ethyl carbocation is formed. Now step 3. Now I'll just move to us the next one. Next one is the step 3. This is your step 3. So what happened in step 3? So in step 3, the deprotonation takes place. Is what? Deprotonation. Deprotonation is what? Removal of proton. So deprotonation. Deprotonation. So what's about the deprotonation? Removal of proton. So have a look here. Removal of proton. Removal of proton. So removal of proton and formation of alkene. Formation of alkene will take place. Alkene, as the proton will get removed, alkene will take form. Have a look here. We have the carbocation CH3 CH2 plus. We can write the CH3 just like this, CH2H. Now what will happen? This reaction is fast. As a slow step is the rate determining step. Slow step means slow reaction is the rate determining step. So that will be studied in higher classes. So how the slow step and what the slow step and what the fast step and how the slow step rate determine the rate of reaction. So that we will study in the higher class. Now here having just think about this. This is the plus charge. This is the ethyl carbocation. This is what? Ethyl carbocation. So this is the ethyl carbocation. Now this carbon lacks the electron. To fulfill that electron, this bond will get break. This carbon hydrogen bond will get break, and it will form a double bond over here, and this will form H plus, and this H plus is out. So H plus is out, means proton which you have taken initially, that is out, because H2SO4 is playing a role of dehydrating agent over here as a catalyst. So if it is out, then it will form CH2 double bond CH2, and this is the formation of alkene. The alkene is formed. So whenever they ask you to write the mechanism of dehydration, then you have to write 3 steps. Step 1, formation of protonated alcohol. Step 2, formation of carbocation, and step 3 is the deprotonation. Now I think you understand this one. Then we just move towards the last method of preparation of alkene, and that last method of preparation is alkene is that is there is some more we have that is from sodium potassium salt of saturated dicarboxylic acid. So what's about that? I just like to explain that. Wait a second. Now I just want to say you one more thing, that this dehydration one, from this dehydration of alcohol, monohydrate in presence of conc H2SO4. Now temperature is also required at what temperature? At suppose 440 Kelvin temperature. Nah? So this reaction is also the lab method of preparation. This is also known as lab method of preparation. Nah? So how just let's, this is your lab method of preparation. Lab method of preparation. Nah? So this is the thing you should keep in mind. There is nothing much to tell about this. Same thing with the monohydrate alcohol undergoes dehydration in presence of conc H2SO4. So it will form alkene. Now we have discussed about the mechanism. If you want to discuss about the lab method of preparation, I am just writing up lab method of preparation of alcohol. The same thing we alcohol. So what do we take? We take the alcohol. Now we suppose we take the ethanol like C2H5OH. And we also add some conc H2SO4 in that, concentrated H2SO4 over that. And the ratio of concentrated alcohol and the conc H2SO4 is 1:3 by volume. The ratio is 1:3 by volume. So and we also we also take using the Al2SO4 whole thrice and sand. We also take Al2SO4 whole thrice, the aluminum sulfate plus sand over there, and temperature we just take 433 to 443 Kelvin temperature. Then and why we use aluminum sulfate as a catalyst over here? So because to avoid frothing during the process. So this one, why we use this one? To avoid frothing. Now froth is formed during the reaction, so to avoid frothing, froth, F-R-O-T-H-I-N-G, frothing during the reaction. So avoid frothing during the reaction, we use aluminum sulfate and sand. Then finally what you get it, we also use some NaOH alkali, which absorbs carbon dioxide and CO2. So we also use what? NaOH over here. NaOH, sodium hydroxide, that is known the caustic soda. So caustic soda, that is NaOH. Why you use in lab method of preparation? So because it absorbs carbon dioxide and SO2 that is formed during the reaction. And why we use aluminum sulfate and sand? To avoid frothing during the reaction, and finally we will get C2H2 over here. So this is the thing you should keep in mind. Sorry. So how the reaction will take place? So if it is a sodium caustic soda is there, So it will react with the carbon dioxide and it will form sodium carbonate Na2CO3 and plus H2O. And if it is sulfur dioxide is formed, then it react with the sulfur dioxide as well to form what? Sodium sulfate. Sodium sulfite Na2SO3 plus H2O. Not the sulfate, sulfite. So this is all about the lab method of preparation of alcohol. This is the same as the dehydration of alcohol. Nah? But there is something is changed because in the lab we form a little amount of alkene, and so we take some precautions like we want to avoid the frothing during the reaction, and we also want to avoid for the formation of CO2 and SO2 to avoid as a byproduct CO2 SO2 directly. So we use the caustic soda which absorbs the CO2 and SO2. Now the last but not the least, which one? So wait a second. If you remember Kolbe electrolysis in alkane, now same electrolysis took place over here. Now so this is the Kolbe's electrolysis method. Kolbe electrolysis method. So what you take in this case to get the alkene? So we take sodium or potassium, salt of saturated dicarboxylic acid, and with water it undergoes electrolysis. So electrolysis which you have done in formation of alkane, same electrolysis will took place over here. Now so have a look. I will just give you the one example directly. Suppose we just take the CH2 C double bond O OK and the CH2 C double bond O OK. This is the potassium succinate. If the potassium succinate is electrolyzed with H2O, so what will happen? So electrolysis will take place. We know all about the electrolysis. Then this is the electrode, cathode and anode. We have also discussed in redox reaction. So this is the cathode, red cat reduction will take place at cathode, anox, oxidation will take place at anode. Reduction is what? This is the gain of electron, and oxidation is what? Loss of electron. This is the basic fundamental thing, so you should keep in mind. So what happens? So it will form what? It is okay. This is so it is first write on the byproduct. This carbon dioxide will form as a byproduct. Hydrogen plus potassium hydroxide is the byproduct. What is the main product? Main product is alkene, ethene. Ethene is what? CH2 double bond CH2. So this is your ethene is formed. Now you just move towards the mechanism part. So how this reaction took place. So we just take potassium succinate, CH2COOK and the CH2COOK. Now ionization take place as you put in this water. So since this is a covalent compound undergoes ionization, and the ionic compound undergoes dissociation. So this is the covalent compound, then it will undergo ionization to form CH2COO minus and the CH2COO minus plus 2K plus. Now what is also is over here. So H2O will dissociate into H plus plus OH minus. Now we have two we have two cation like H plus and K plus, and we have two anion. What the anion is? CH3CO minus, succinate and ions, and OH minus. So now we just write over here the cathode and anode. So as you remember, I have explained in the redox reaction. So which have the less discharge potential. Out of this to this will undergo reduction, because this is less reactive than potassium. So 2H plus plus 2 electron, so it will give you H2. Now out of this, OH minus and CO minus, COH minus is will give more priority to this one. So CH2, COO minus and COO minus. First it will lose, it have more electron, then it will lose 2 electrons. Then is a gain of electron, so it will take place at cathode. Is a loss of electron, so loss of electron, first it will form just like this, CH3COO and CH3COO, but this is the less stable because as it forms CO2 over here, so it will form 2 CO2 molecule, 2 CO2 molecule, and this is CH2 double bound CH2 you will get over here. Now CH2 CH2 double bound CH2 means ethene is formed over here, and 2 molecule of CO2 is out from here. So it will take place at anode. What's about the rest one? So rest one is potassium hydrogen, so 2K plus will react with 2OH minus, so it will form 2KOH as a byproduct. So we also get the byproduct KOH hydrogen and H2O so and CO2. So this is the overall reaction for the method of preparation of alkene. Now I'm going to make a flow chart for you. So flow chart is very important one, so you should keep in mind, it will helpful for you for this is the flow chart. We will start with the flow chart. We have started the reaction from first we have started from the alkyl halide, isn't it? So first one was the alkyl halide. So alkyl halide, we have taken alkyl halide. Alkyl halide undergoes in alcohol, in presence of alcoholic KOH, it undergoes dehydrohalogenition. What? Dehydrohalogenition. Dehydrohalogenition to form alkene. Now the next one is what? Next one we have taken vicinal dihalide. Vicinal dihalide means what? Having 2 consecutive carbon have halogen. So this is the vicinal dihalide. Vicinal dihalide in presence of zinc and alcohol, it forms alkene. So this is the vicinal dihalide. Now also geminal dihalide also forms. So geminal dihalide is what? The same carbon have 2 halogen. It also react with the zinc and alcohol CH3OH to form the corresponding alcohol. Now we also form now the next one, I think we have the alkyne. From alkyne, so alkyne is what? Alkyne is C triple bond C like this. This is your alkyne. So with alkyne, either we can take the Lindlar catalyst. What do you say? Lindlar catalyst. So what's about the Lindlar catalyst? If you remember, then BaS palladium plus BaSO4 and sulfur. Why the BaSO4 and sulfur is taken over here? To poison the reaction. Why the poison reaction? To stop the further reduction. So if the alkene will further reduced, then it can form the alkane. So as the alkene is formed, this BaSO4 and sulfur stop the reaction, and only we can get the alkene. So this is not the partial reduction. So we use the term partial reduction. And what it will form? It will form cis alkene. Cis means you remember what the cis is? Cis is having 2 same alkyl group on the same side, and the means same group same alkyl group or the same group of groups are on the same side of the both side of the carbon, isn't it? So now the next one we have taken RC triple bond Cr. This is what? This is also the alkyne, and the alkyne in Birch reduction. We just do the Birch reduction. BIRCH Birch reduction. So what the Birch reduction? So Birch reduction is took place in the presence of sodium in liquid ammonia. And what is formed by this? then it forms trans-alkene. Trans-alkene means alkyl group on a different side of opposite side of the alkene, means opposite side of double bond of the carbon. Now the next one we have, wait a second. Now this is we have done with the partial hydrogenation, and is anything more? Yeah, that is the Kolbe electrolysis. We have Kolbe electrolysis. We just write over here Kolbe electrolysis. Kolbe's electrolysis. So what's about the Kolbe electrolysis? The Kolbe electrolysis for ethene, we just took the sodium potassium side. This is the potassium salt of dicarboxylic acid. So this is what? Potassium succinate. We take potassium succinate. So when the potassium succinate undergoes electrolysis, then it also forms this one. So we have very less reaction over here. So I just like to, how many reaction we have? Is anything left? Dehydration we did it. Wait a second, dehydration we did or not? No, we didn't do the dehydration part. So dehydration of alcohol. We just take the alcohol, and alcohol with a conc H2SO4, it gives you alkene. And this is also the lab method of preparation is also over here. So this is all about this 1, 2, 3, 4, 5, 6, 7 reaction. Only 7 reaction we have. Is any reaction left? I don't think so. So these are the method of preparation of alkene. In next video we will cover the properties of alkene. So what's the physical and chemical properties of alkene we will cover. So till then, take care of yourself. Bye.